I want to say welcome. It's nice to see you proud. I'm Lori Ellis. I'm the president of the Storage Group, which is Real Estate Society of Masters. And I just want to thank the library for hosting us here. It's a much nicer, cooler place than our little blockhouse we see. It's just, if you don't know, how many people that rich people? But most of you have. It was built in the 70s, and it holds a lot of Brewerton history as well as current history. We're trying to build that in too, so that we don't forget it. Today we're going to have Donny, who is our curator. Donny Abend is our curator. If you've ever been on a tour there, he will give more information than you could possibly absorb on a tour. And Casey Burns is going to also be speaking today. He is the technical engineer of the communication. So, the fort is solely run by volunteers. Everybody is just a volunteer. We're always looking for more people to be active, to come and visit, to attend our functions. And so, if you haven't been, stop over. If you're interested in becoming a member, there's a brochure with some more information. And with that, we'll let Donny and Casey introduce it.
Good afternoon. So a lot of the materials that we have from Ellen Milligan down in the basement, just a lot of newspaper articles, it's where I pulled most of this information from. It's just going to be an informal talk about our Brewerton Bridges history, the different phases of the bridges, and why we needed a bridge in the first place. So here's a map of Fort Brewerton. It's about 1759. And you can see in the old days, you had the ford across. There was a shallow area. It's not dry. You're going to get your feet wet. And during the wet months, I think they said a horse could get across. That's about it. And during the War of 1812, apparently the militia struggled to get across this, so it kind of raised some flags. So the state, here's the floating area. There's another one over by the railroad track where that eventually was put in. So a ferry was put here by Jonathan Evans in 1813. It's in the newspapers. I have some copies open over there if you guys want to look at them. They're very fine print, whatever the magnifying glass. After 10 years, when his contract was up, the legislature gave him the ability to put a bridge in for a toll. The toll house was bridge, the gate was originally here on the south end. And there was no draw for the bridge. You had to put your sail, your mast down. It was a low under the bridge. So here we are in the 1870s when the bridge has been repaired. It was 1846. They put in a drawbridge and they moved the toll gate to the north side. Here's a picture of it. This is late. This is like, as you see the Fort Brewerton house that was put in 1849 when they tore down the blockhouse. The original blockhouse. This was toll gate. The draw was, I think, in the center. I'm not really sure. I don't have a photo of that. But it may have been towards Abend. It's built and maintained by the Brewerton Bridge Company. I have some of their artifacts here. Construction supervised by E.B. Judson using timber supplied by the first settlers. So because they supplied the materials for it, them and their descendants got free toll for the bridge. For existence of the bridge. It was 18 feet in width with a 6-foot curve in the center. It keeps the horses from bumping into each other. So it's 560 feet in length, approximately. Pine timber stringers with 2-foot square pier to pier. There were 10 to 20 pier or 10 to 15 piers. Ellet's not sure is those. He's listening to old timers and stuff. This bridge didn't exist by the time he was born. 20 feet wide, trunk house filled with stone. So Case will tell you that those will survive forever as long as they're submerged. They don't rot out.
But yeah, when Donny could have looked. Donny showed me his presentation or his slides a while ago. We started looking and talking about it. And it's really interesting because I'll go through my whole pitch. If they want to hear a pitch and be bored about what beams are and how they work, and we've done that before. But essentially, what's really cool here is we've built this essentially without any power equipment. I can with local materials. Most of the materials are made natural, I should say, well, negative and natural. So there's some inconsistency together. It's built out of wood and stone, and that's what they build it out of, wood and stone. And we got talking to Donny. Much of, even for a century later, much of the infrastructure along the canal, the foundations are on cribs that are made of wood and stone. Stone is ballast and it's heavy and it's compressed and it's indestructible. Wood rots. Well, what rot is essentially is a microorganism, and eat it. They eat it. You break it down, insects go in and together. When you're completely submerged, there's a lack of oxygen. There is some oxygen absorbed in the water. Fish live in it, right? But it's much lower concentration. So what found out is they would build a rock crypt, you take it out and sink it, and fill it up with rocks. And that gave you a foundation that after probably some initial settlement, then they built the piers, which you can't tell me from that down into a picture. Out of the water was built with stone. They laid up stone to get the height, get up above. I would assume at that time there were more concerned with floods and traffic, which is why they kept it 1 section deep. And then they had the spans were regulated then by the strength of the timbers. And that's how it came to this height. And so the first bridge was made by local people, by Ian, since we got the native materials, which is why you end up with a design receipt.
Is that looking at the North Shore?
What?
Where the current?
So that's the fort. That's the Fort Brewerton now. So that's the North Shore.
That's where the fort was.
Yep, the fort is just beyond that.
Yes.
The earthworks are. These 45-degree timbers here are for breaking ice when it comes off the lake. And I believe they're just made out of pine. They're sacrificial. But the flooring is made out of hemlock. That's for like wear, right? It doesn't.
Yeah, hemlock weathers. Yeah.
But the rest of it's just pine. It's been weatherproof. It was repaired and upgraded in 1846. That's when they put in the plank road. The toll gate was moved from the south to the north side. I'm not sure why they did that. It might have just been easier for the toll keeper. The drawbridge is added as the river traffic increased. They get some ships. They got to get big ships through. They can't put their masts down.
How did they lift it?
They didn't lift it. So this bridge was not lifted. They just put in the draw. It was probably like the next bridge, probably just 50-foot wide space to get boats through, where they could just get the bridge out of the way.
I'm gonna guess they probably have to stiff legged cables with up and down somehow.
It was simpler than the next bridge. The next bridge is going to have a gearing. This one was just wheels on boards, just kind of straight in. It was abandoned by the Brewerton Bridge Company in 1877, and the state took it over. The local government took it over and demolished it in 1882. Then there's a picture facing south. You can see the Washburn Hotel. You can see it's in bad shape. This is late in life. It doesn't have the curve anymore. So this is the Iron Bridge. This is what came after. I think it has less spans, but it's stronger. And it's also very light for an iron bridge. It's like almost like sheepy, right? It's not thick curves.
It's not.
It's not like this bridge. It's not as thick.
No, it's much lighter. Yeah. It's interesting because there's a truss. That's a relatively new detailed design. Behind there's a way to increase the span. You can only increase beam size so much in order to keep the beams. Usually, in something like this, they'll dip or they'll break and bend. They make them thicker to help that, but there's a practical limitation. So they transferred the load up and around. It's almost like making the beams thicker without actually increasing the beam. There's a little bit of math to it, but.
And they figured this is the south side because there's a lot of boat beating going on here, and the south side is. I don't think this is the north side. So I'm not sure what this is. I originally thought it was like toll gate related or something. It might just be related to the boat manufacturing.
We went from dozen spans, whatever it was, to 5 spans.
Yep.
Which increased. Well, it allowed them for the local river traffic. It was getting heavier.
The steel was provided by the Homestead Iron Works, Pittsburgh, Pennsylvania, and a ferry was operated. You'll see that a lot. Every time they're working on the bridge, they're going to get a ferry operated. And Ella took pretty good notes on who was running the ferry. The Seymour, Auburn, and Cicero. 2 piers of solid masonry, or new piers of solid masonry, 100 feet apart, were placed on parkland. So we were wondering if they went down to the bedrock. They didn't. They just put it. They got through the silt as soon as they got the hardpan. And they said it was really strong. Ella noted that it never had any issues with strength. Underwater work was actually done. John Yu had a suit like one of those you see in the old movies with the glass with the reinforced. I don't have any pictures of it. He had a steamboat named Teaser. It didn't track down any discs. We might have them. It's completed April 9th, 1883. Contract price of the ironwork was $13,526. The state gave $5,000 if they promised that they would not have to maintain it. No more money after that. They give you $5,000 up front. 5 spans, 4 stationary with 1 draw. And this was a little more complicated. It said gearing, and it actually turned out away from out into the channel. 25 feet wide with 8 feet plank flooring. You can see the curve here. 6-inch curve, the center to separate traffic. A geared drawbridge on a turntable. So give you about 50 feet. I think it was 48 was the usable space for a boat to get through. I like this picture here. There was a fine for speeding anything faster than a walk. When they eventually went to automobiles, I think it was a 15-mile-an-hour speed limit. So, they're worried about the bridge. This bridge, because it's so light, it was never designed for automobile traffic. And these didn't carry very heavy loads for horses. There was a limit how much they carry. As soon as we got automobiles, they were pushing stuff across the bridge it was not designed for.
You can see from this picture, it is a very light structure.
It's fancy too. It's got decorative things built into it.
Yeah.
But the first thing that happened was they had to raise it because the barge canal was getting put in. So in 1908, they put in this cribbing here. Casey can probably talk about what they're doing. I actually have a close-up of it right here.
We thought this was really interesting. We were looking at, hey, look at that. It's very simple. It's just a jacking and cribbing operation. You jack whatever you want to do. Jack it up, and then you come over here and you put some cribbing under it. Right? And you release your jack, and then you put your jack on cribbing, and then you take your jack up, right? And you do these steps. But what we got looking, Donny had this. Look at this guy right there. To me, that looks like an old, and I've seen them, an old screw jack. This was before hydraulics. Right? This was all mechanical. You either had to get a big lever arm, like a hard jack, to make it big. That's heavy. And jack came up. Or they came up, we have these screw jacks, essentially a big nut, a hollow pipe and a big nut. And they put that.
You may be doing it here as well.
Well, there are 2. There's probably 2 to make this work. Because they'll have one under each. These bridges are designed for the weight to bear down on these piers. There's a bearing spot on all these bridges. And that's where you would have to jack it. Otherwise, you risk bending something. It wasn't made to carry that load. So somebody else had to figure out where to put the cribbing. And I suspect we got this one in the air. I couldn't really tell. They probably reinforced the bridge right in that area somehow to keep it from tripping.
And this is Elliot Milton. He was probably about 25 at the time, but he was he's the old historian that gathered up all these notes. I think that was me because it was in the white sweater.
Yeah, he spent his whole life here. Like I said, he was the historian. We thought Donny looked at it and said, that is kind of interesting.
Yeah, I love these old photos because this is postcard sized, and you can really zoom in and get some detail. You can't do that with the newspaper clippings that we're going to be getting soon. Later in the presentation, it's going to be a lot of cool. You get newer, but the photo quality decreases because that's all I got. So here's another photo of it. What they're doing is they're putting another span in. They took 2 spans out, center span, and the pier to go with it. And they put in a. Go ahead.
No, go ahead. You're going to say that.
And they put in the superstructure.
Well, yeah, but they also didn't raise the masonry piers. They came in with iron columns, the vents, right? So that was again using manufactured product rather than a natural product, kind of a move forward in technology. Really.
I'd also like to point out that this was the time they actually removed the old pilings that were still underwater from the original bridge. This was built next to the original bridge pilings, so they were still in place even at this point. This is when they removed them completely. As Elliot talked about, you could look on the side of the bridge, look down the water, and see the bridge, and you'll hear the piles yet. So it was built by the Brewerton Bridge Company, 2 center spans and a draw out pier were removed. The canal was dredged to 13 feet, 220 feet in width, finished in late September of 1998, and the ferry was operated by Charles Siegel, a local.
So, Larry, tell me about the brickwork on the center versus on either side of the stand. Why does it have to be arched and more
Basically, is it
Essentially, that's a longer stand. I don't have all the measurements here, but that's almost the stand that's there now. It's probably that was probably very long.
they're very similar in design.
And yeah, what happens there is as the stands gets longer, you've got to carry more load. And in order to get that, you make that structure taller again. Why they did it as an arch and there's a little bit to that, to the mathematics. Essentially, the moment is strongest, you need the most depth in the middle. And you need a certain amount of opening on the end to get your traffic through, so they start there, and then they essentially get the height as they need and bring it down, probably save on some material. But there's also some other considerations. So essentially, that's it. Just to clear that bigger load, across that bigger span.
Would they have had diesel power by that point?
A lot of the stuff they use is steam still.
Steam.
I've noticed that in the records it still mentions a lot of steam, very little combustion. I mean, obviously we got automobiles going on there. This is 1908, it's still pretty early.
You're looking north
I
again.
don't think so, but
So,
relatively soon.
yes, you can just barely see the Fort Brewerton house in the background there. And this is Smith's, or what will be Smith's Pier in the next photos that we see in the next bridge. Smith's Pier gets built. So I don't know what the structure is in front, but it's whatever was there before Smith's
Well,
Pier.
Have you seen Orlando's restaurant, basically?
Mm-hmm.
Right, at that point.
Mhm.
Where that building is, was that Orlando's leaving?
That building, I believe, yeah. So I think it's called the Lakeview at this point. I'm not positive.
Donnie, the question was, at this point, was the railroad bridge built yet? Was the railroad bridge built?
Yes, the first railroad bridge was built. You saw on the old map in the old map I showed you on here.
Yeah.
That was 1873. So it was built somewhere around that time. I don't know exactly. There's been 2 bridges though. The new one that's the one that's currently in place, I believe, is in place in this photo.
Also, for the
Or in this time. And this is a view up Main Street going north of that new bridge. There's still a lot of horses still being used at this point. So here's a picture of 1927. The date's wrong, if that even is, but it's not 37 because the bridge doesn't. This bridge isn't there in 37. So this is an interesting incident that happened. Just one of the things that happened after the bridge was improved and more traffic starts going through this naval vessel that's stuck. A nice view of the old boathouse. At this point, it was owned by H.W. Smith of Smith Corona Typewriters, and he had this wonderful yacht, that big yacht there. And he owned Denman's Island at the time.
What was his name?
H.W. Smith, of Smith Corona Typewriters.
That's the same Smith as Smith Corona
Yep.
typewriter.
This is in 1927. We had a really bad ice storm, and all the telephone cables got ripped down. So it makes a really cool photo. Messed to clean up. And then this is kind of like the harbinger of things to come. The bridge is nearing the end of its life. Years of the heavy automobile traffic began to stress the bridge as it was designed for horse-drawn traffic in mind. In 1928, cracks were discovered in the members of the Golden North span requiring emergency repair. I actually originally thought the bridge was condemned at this point, but they tried to reinforce it until they got funds to repair the new bridge, to create a new bridge. Because just like here, it took forever to get this bridge. Even though we knew this bridge needed to be replaced, it took a while to get the funds and plans together. So they're trying to give it a little bit more like, look at the old cars driving up on it, just barely make out the silhouettes. It's like a Model T or something. A pontoon bridge was used in December of 1928 and January 1931. Every time they were doing repair work, they didn't want to disrupt traffic, so they put in this pontoon bridge. Which brings us to another view of it right there in place. This is my favorite photo of the whole bridge collection. This is nighttime view of the pontoon bridge. This is 1931, the second time they put it in. It must have been so cool to just drive across that at night with the lights lit up like that. This building here is still there, so the fort and the blockhouse are over here. So that's over by the boat, just before you get to that boatyard that's there on the north side. I don't know who lives in that house. And you need a ferry again to move the once that you can't have that pontoon pier there all the time. You got to have traffic coming through. You don't want to block the canal. So ferries are the answer. They've always had been. But this time they built a big one and it's privately owned. The guy's charging everybody 50 cents a trip, and they weren't happy about it. The locals didn't like it. So you had two options. You could either take the ferry, pay 50 cents a trip, or you could go to Codnoy. It was like a 10-minute trip. And you do that today when they do this bridge. They're either going to have the single lane bridge to go up and down, or you can spend the extra time to go to Codnoy, which I might actually do because I work right at the site, and I don't want to do a temporary traffic that's going to be there. So they draped a cable, and it's steam powered. And then whenever the barge isn't being towed, you just drop it into the canal and it just sits on the bottom. It's the way it's always been whenever they've done these cable ferries. Not popular. The guy actually got into trouble when he this guy right here, Benjamin Lesson, got into trouble when he removed the signs for the detour because those are like state. There's some kind of law you break when you remove safety signs like that, detour signs. And because he got upset that people were skipping out on 50 cents. So he actually got arrested for that. I don't know how much trouble he got into. Here's a nice view of it. There's Smith's Pier, right there. It's the barn. And this, you can at this point, the old bridge has been removed. You can just make out that little addition that they propped it up with right here. There's the button. There's the end of the.
Well, that's the first band.
Yeah. So they're already tearing it out and working on putting the new one in. But before they do, they got to completely scrap all those piers. In this picture here, it's just like today. We asked, what's going on? Why is nothing going on? It's just sitting here. It seems like that same way today. But it takes a while to do this. It's a lot of work. Casey said they've moved all this dirt out onto to give them a work area out.
Yes, it's like they go the causeway part way up, the access to the piers, which they have to remove yet.
Got to put poppers in.
All that stuff.
Yeah.
When you're building these,
It doesn't look like you're doing a lot, but they are.
Below than there is above. Everybody thinks it looks like there's nothing going on, but all that work is happening out of sight, down below, down in the ground, it goes under the water.
And I don't know the exact mechanics involved, but they use ferries to get the bridge off and to put the new one on. They're putting a ferry underneath, and they're pumping the water out of it, and it raises up like. And you don't need a crane or anything. You just move the old bridge off with a barge, and then build the new bridge on a barge and float it down into place.
Yeah, you ballast the barge low, and you bring it up, block it up tight, and pump the water out.
They might even do that. Do you think they'll do that?
Itself back up.
Do you think they'll do the new one that way?
Yeah, we're talking about that later on. My understanding, the demolition will be done probably with a single barge and pull it off. We can talk about that later.
Yep.
Or there's a possibility that they come off and get a double barge set up and pick the whole thing up, still later, or move it up or down the river. It works. I've done them both.
So this doesn't get dismissed.
This is the old bridge center section, and it was taken off intact, placed to the side, and cut up. It was noted by Elliot that it was still in really good shape because it's newer than the rest of the bridge. It's the old sections that were shot. This, they just cut up for scrap. It wasn't worth reusing. They could have.
Well,
It was only 2 decades old.
older than that shape. But there have been times, rare, it's rare that you have an opportunity to take an existing truss bridge or something, right? Maybe it's just, might be in decent shape, but maybe it's just a passing one. And then find a place that'll actually fit. You have to have a site that has to be essentially the same.
Save yourself a lot of money if you can move it.
I remember I don't want to, but not 20 years ago, but when they replaced the Belgian bridge, with Longville, that truss bridge actually did go down the upriver. It went to a county site somewhere over by Capsule. Exactly where, yeah. That one was actually, it's rare, but it can happen. Yeah.
The plans for the new bridge called for a 377.5 feet span to the center span, with two 85-foot girder spans. Oh no, sorry. The whole length is 377.5 feet. Two 85-foot girder spans, and then the superstructure is 207 foot truss. with a width of 50 feet, including 5-foot sidewalks. This is the first time we get sidewalks. Before that, the bridge just didn't support the extra weight. The work was done by the Lackawanna Bridge Company of Buffalo, New York, subcontractor for the Peckham Company. I don't know if they're still around, but it's possible.
I don't know which Peckham company that might be, but there's a Peckham company that's still around and a different owner now. It's in their Kitsy area, they're big highway builders. The Peckham name is still around.
And you can see that it's much greater cost than the old bridge, $138,660. Steelwork arrived on barges, the GM Waldy and the St. Anne. They were told by the Tug Cornell. I couldn't find pictures of them that were good. I'm pretty sure they're in these pictures, but they're just so pleasant you can't see them. This is the new bridge, built on a barge to be floated into place. In the background, you see the railroad bridge. And there's a guy right there. See him. So they brought all the steel in on those barges, and they built it on the barge, and they floated it into place.
Yeah.
And here it is being floated into place. It's not quite on the pier yet. And these are the barges here.
In this case, it'll be just the opposite. We'll take it over, give it a line, and tie it off or secure it somehow. Then they'll pump water into the barge and then it'll sink the barge. The barge sinks, the bridge comes down onto its bearings.
And they can do it very slowly, right?
You do it very slowly. You do it very slowly. Yeah. Pardon me?
What is the structure get done?
Right on the side.
I don't know
In
what
this
it is.
case-
But normally you'd have maybe a dock area or peppers set up, and then you'd have your crane crews who just you're building it right here in front of you, rather than out in the middle of the river. Right? So you bring the parts in and weld it or bolt it, rivets. I don't know what to use for that. That's probably still riveted in the original. They would build it, stick build it right there, like the director set, on the shore. But they would build it up on that shore. Ready to go. Yeah, on the barges and on the shore, and they erect it there. Now, when it was complete, off they go. They fold it up.
And unlike the other bridge, the iron bridge before it, and this one I think is concrete piling, right? And they're probably going all the way down to bedrock.
I don't know what the piling is for. I think kind of be surprised.
I see it decaying. When you go down there, you can see it crumbling. So I think it's.
Well, here's a concrete.
Yeah.
I don't know what the piling is.
Oh,
Back in the 30s. I would almost guess it's steel, but I don't know.
and here it is finished. November 6, 1931. That's the one we have now. That's the 1931 bridge. Which is what I call it. I think it's called the highway bridge. Here's an aerial view of it in 1937. What's going on here is every winter, all the canal boats, they pack up in Brewerton ready to get out on the ice as soon as they can. So they just kind of make this huge traffic jam. And you can see the Smith's Pier is right here. There's the observation building. It's been there in a lot of the photos. Here's Brewerton here. Here's the Washburn House right here. And there's the railroad bridge. The bridge had to be raised. There was funding available. It needed to be done, but hey, we got the money. It was $35,000 to raise it up 4 feet 9 inches. And I don't know exactly how that was done. Casey could probably explain how it's normally done.
Yeah, Donny asked me.
It didn't stop traffic. This just went on over a period. Started in May and ended in September.
In this case, you can see there's a lot less going on to raise the bridge than there was before with all the jacking, blocking, and people. I suspect
It says
here, by this
21
time,
hand and several hydraulic jacks.
the hydraulics were in use here, so they would. In that case, you could have a series of jacks. You raise one jack, right, do the same thing, dog it off, raise another jack. But it's hydraulic, and there's a lot less earth in there to go over.
And then when they were done, the steel work that they put in, they encased it in concrete. I do know that. So that might be the decaying concrete that we see now.
Yeah. Well, those piers are.
How high did they raise that?
4 feet 9 inches.
4 feet 9 inches?
Mm-hmm.
That was for the barge clearance?
Yep, they wanted all the bridges to have to be higher, and they wanted the dredge to turn it out deeper. So all the bridges got some money from the government to do it. It was millions. But that's a lot of bridges. Here's an aerial view in 1955. The pictures get newer and they get worse. And here we are today. Now, maybe Casey can talk a little bit about the new bridge.
Yeah, like right. I don't know a lot about it, and I don't want to speak for the state or the contractor, but I do know a little bit about it. Talk to a few people. It's essentially a truss bridge. It's essentially what we have now, but the truss design has been changed. And it is a slightly different design. They call it a gussetless truss. There's only one other one in the United States that built this one. And all these little members, remember in the other pictures, there's lots of members in a truss. And they're all individual pieces, essentially. And they're hooked together with rivets or bolts nowadays. But the way that goes is there's just a plate, basically, on both sides of the member. Right, and holes all lined up, and then you put your rivets in. That plate is called a gusset plate. It's just a name, it's a gusset. So what happens, though, is that that plate is nice and tight when you first build it. But there's always movement, and water gets in there. When you have a tendency to get rust forming at these intersections, and it's higher maintenance. Gusset plates need maintenance. Not every day, but they have a tendency to wear out. So they like the design. We're going to try to keep a truss bridge, I guess. In New Hampshire, the University of New Hampshire, and how they came up with the plan, but they decided to want to design a truss that didn't have these gusset plates. Let's do away with this maintenance plan. So they came up with it's very similar when you look at it from a distance, and I'll pass this out. I just got this up in here a few days ago. And on all the pictures you can remember, go back, that picture that. Look at that. The bottom is always heavy, right? And there's 4 beams that go across the carry below, but the bottom, that's a greater bridge anyway. Even here, see how the bottom members are heavier than up here. That part that they lifted up is light, smaller. The new gusset bridge is similar in the fact that the bottom members are heavier and the upper members are still lighter, but they don't come together with a gusset. What they've done is they've designed literally a tapered or rounding effect. They fabricate the beams, the lower, heavier beams, to take all that tension, and they essentially built a curve, a linear sort of structure, and all welded together. It's a complete unit, right? They're going to fabricate these, and then the other members are put together. Even the tops are gussetless. Bottom's gutless, tops are gussetless. And the parts in between that you need to put it together, and even the bottom, they have plates. They're not. These are slightly different. They're splice plates. You still have to have plates. So we're still going to use splice plates, which are on the web and the flanges of the structures, part of the beam. But essentially, they've done away with all these myriad gusset plates. See the plates there? These are all individual plates, and everywhere there's a connection is a plate. They're doing away with that. And this is the second one. It's been designed with some tests done for longevity and the way stresses are transferred and all kinds of geeky things. But this is going to be the second one in the country called a gussetless truss. And it's just more of a streamlined design, more welding, less punctures, less bolts, less maintenance. Well, that's kind of cool.
The other one in the country, how old is that?
No, it's we don't know if it's going to work yet or not. Is that what you're getting at? Yeah. No.
It's currently being tested.
No, I should know that. It's just something very recently.
Casey, it looks like a Bailey panel bridge. That gusset we used to build Gary. We just pin them all together. We take sections, build it, roll it up, pin them together, and just build it with no superstructure up above or on the side.
Yeah.
So I looked at a picture and it's a Bailey panel bridge.
Yeah, well, essentially a Bailey panel bridge is little mini truss sections, right? That they're all connected together.
Yeah.
And you can stack them and you can put them side by side.
Yeah.
Now that you say that, what's happening out here in general? Just because people always question, and I wasn't sure. I was only getting ready when I first went to work. So I was getting ready to go and put the temporary bridge in, and I realized no, they're not. It's a really nice plan that they have. The contractors come in, and because there's very limited space on most bridge sites. There's a very limited space. And what's going to happen? Donny's got pictures up here too.
Oh, this is the library.
The library has pictures. Well, here you go. Here's your gusset with connection. Here, they fabricated these without any connection pieces, and that's kind of the key. Some people have not seen. That's really afterwards. That's kind of the key. Now these pieces still have to go together. You can see, like here, there's a splice plate. Here, there's a splice. There's going to be mechanical splices there.
So as long as your welds hold, you got nothing to rust.
Well, most bridges you drive over nowadays are basically fabricated girders. Like they welded pieces of metal together. So that should work pretty well. And what's going to happen over here, of course, we all heard about it, there's going to be a single lane temporary bridge, which will essentially be a modern day Bailey bridge. There'll be approaches that are reinforced earth approaches. They'll be relatively narrow. You'll see a block of dirt. It'll stand up like this. It doesn't have to have slopes, but they'll have mechanical ways to tie that together. Essentially, it'll be fabric. It's kind of comes back on itself and the weight and pressure. It'll stay together. And then there'll be a single lane bridge with a temporary traffic signal controlling single lane, right? One way, one way. It's going to be slow. One way, one way. So what the contractor did was came up with a plan. Basically the footprint of where the temporary bridge is going to go is their only access. They decided to go under the bridge, put their coffer dams in, and start to install the substructure for the new bridge underneath the existing bridge. The headroom's a little short, it's a little tougher to do, but they're in there getting ready to put the substructure in and bring the substructure up this summer. Then their general plan is, as I understand it, and we'll read this, but this fall they will erect the temporary bridge and operate that temporary single lane bridge through the winter time and take down the old bridge during that time and begin the erection of the new bridge and hopefully have the new superstructure up before springtime and then that's when the final is supposed to be done. I've talked to a few of those guys recently, and their hope is to have that superstructure up by next spring.
Temporary.
Good question. Yes. Yeah. But one of the things that they're doing it this way. There isn't any, because they're going to try to do it in a minute. That's one of the reasons I want to do it that way. Because there will be the demolition part. It will involve some barges of some kind. They probably are going to pick one end up with a barge, pick the other end up with a crane, have a roll-off structure. We've done it that way. I know they have two. And you roll it to yourself. You remove part of it. And then you roll it to you, you remove part of it. You keep rolling it to you rather than pick the whole thing up, bring it back. There's really no place to work along the river. Right, so I suspect that's how they're going to do it. And I suspect the new bridge might go back in the same way. But it also might be erected somewhere else, but that'll be offsite because there's no place to erect it. I don't think they've made that erection procedure hasn't been approved every year. But that's essentially what's going on. And then they hope to have that in by next spring so that they'll free up the canal system again. And then they'll finish, they got to pour concrete back, and there's work to be done yet next summer. And then they hope to have it open by next fall. Done. So that's the general plan for the contract.
So when you did the first talk about the 800, you said that was a new design, right?
Yeah, that was really new.
And so how often are bridges redesigned? Like, is there something about Brewerton that
It's in the water. It's something in the water.
I'll take point again.
I don't know. Yeah, it's kind of thought the same thing. It's kind of odd, right? Back in the 60s, we were the second bridge in the country, the biggest at the time, to ever use that post-tension, right? Pre-stress and post-tension concrete bridge, which is a European concept. This is a homegrown concept to try to how to get your maintenance expenses down on the bridges. Yeah, we're just, we're open to it, I guess, and we're lucky. And we have, look at you, we have less bridges in Pittsburgh, but we have more bridges than most people. So, yeah. So that's what I know about the new bridge, and I think they've made a pretty good start. I just printed these off. This is a picture of the bridge in building the bridge in New Hampshire, and some sales information from the Chicago Metal Roll Products that made basically made the structural pieces, and some stuff from the DOT in New Hampshire, and then actually the results, which I found a little interesting, of the testing they did at the University of New Hampshire, I think it was, when they first started to see if that whole concept would work or not. So, and also Donny has these, but we're going to have this point.
Yeah. So I got copies of the small copies of the newspapers that in the beginning of the presentation I showed some newspaper clippings. They're in the notices are in those. So if you just want to see what the newspaper looks like. I've also got some artifacts that will be on display at the library after this. I've got a stock certificate from 1858 from the Brewerton Bridge Company.
Oh, wow.
Carefully, that's it. There's a receipt book from the Brewerton Bridge Company from 1872 to 1876. It's carefully read. And this is like more of a large cash flow. We got a lot of these hit the fort. They're kind of boring, but this is for the Brewerton Bridge Company. 1848 to 1877. So this is the original bridge, the wooden bridge. This is their cash flow. And all these books are available to read in our library. You can't take them out, but you can read them on site. We've got a lot of old cash flows and other documents. All part of Ellen Milton's library's collection that he accumulated over the years and then gave to us when he passed. If there are any questions? Yeah.
I remember over the years they were constantly repairing the existing bridge. Every few years. What essentially is the problem with it? I mean,
well, I don't know what the latest. I don't know what the latest inspection report says, right? But I do know. Remember, a few years back, they had to put new floor beams in. Temporary floor beams had to pull them up. All those metal pieces start to rust.
If you walk along the bridge, you can put your hand through where girders used to be in some areas. They've rusted. I don't think they're support members. I think they're more just they're not like load bearing, but they're a problem. The rust is spreading and it's eating right straight through the metal.
The floor beams are bad. Yeah, and that's a typical problem with a lot of customers. And so I know they had to repair them. And the bottom cord, which is in tension, I know they did some work on those over the year. There was a barge parked underneath for one whole summer over on one abutment. I don't know what they did under there. But they've been trying to maintain it, and they've known for a while that.
And like I said, I've been under it. The concrete's crumbling away. You can see rebar in places. It's reaching the end of its life. No, everything rusts. It will last a period of time. They all have life spans. Yeah, we'll probably be gone.
Oh yeah, but the idea being that if you eliminate the places where you have holes and connections, then you eliminate a spot that can go bad. And so they're trying to just reduce the amount of maintenance over the years.
Which is cost.
Is the temporary bridge is just to the right?
Yes, it will just to the right here. They've already cleared out here and they cleared out here, so they can put in a temporary bridge.
Isn't it going to be steep to get to
Well, there's actually it's going to be the actual temporary bridge is going to be fairly close to the existing elevation, and it's not exactly right on it. The road, these two areas where the trees are, that's where the fills are going to go, and they'll be mechanically tied together earth fills.
This is the fort right here. The blockhouse. There's like a someplace going to be bridge comes out just past where the pier is. So, give you an idea how
It's
gonna go.
very tight.
Very tight.
There's not much.
It's only
This
one
is what the above. This is what the approaches. This is a cross section of the approaches, and it's taken in different locations. But this is say this is an existing bridge, and this is where the slope comes down. Fishermen are all over here. And this is just graphic. This is where the reinforced earth will come back. And this is all the earth fill. We'll be driving here until you get to the.
It's, you're gonna be starting.
You're starting right at the road elevation. Yeah, and then it's by the time it gets to the river, it will be 20 feet high. In a very it's a fair amount of fill.
That's gonna be so. When you don't have to go over.
Unfortunately, I live in Cicero and work on the other side of the bridge, just beyond the fort. That's why I volunteer there. So I'm gonna have to cross them.
This is a profile of it. I'm going to give this, and the Larry behind you when I'm done. This is the profile as it was planned, the Larry Bailey Bridge. Okay, that'll be the profile of that.
That was a fairly steep grade.
Yeah. This is the detail section of the what the new bridge is expected to look at.